Hello friends, how are you? Good morning, have a great day. Today we'll start with disaccharides, today's topic. So first of all, the definition, what are disaccharides? So disaccharide, di means two, that means they have two monosaccharide units, right? Disaccharides consist of two monosaccharide units which can be similar or dissimilar. For example, we will take lactose, it consists of glucose and galactose. Glucose and galactose are two units are different. In case of maltose, we have two glucose only, right? Those same molecules are there in maltose, but in lactose we have two different dissimilar units, right? Now coming on to the bonds they are held together by glycosidic bonds, right? Properties, there are three basic properties of disaccharides, that is they are crystallized, water soluble, and they are sweet to taste, right? Now coming on to the types of disaccharides, they are divided in two categories. First is reducing and second is non-reducing, right? Reducing because they have free aldehyde or keto group. Examples are maltose and lactose. In case of non-reducing, they have no free aldehyde or keto group. Examples are sucrose and trehalose, right? Now coming on to our first disaccharide, that is maltose. The code is Mg, right? M for maltose, G for glucose. It has two glucose units, right? Held by alpha 1,4 glycosidic bonds. Two glucose units are there. It is also known as malt sugar, and maltose is hydrolyzed by maltase. Ase that break down maltase is maltase enzyme. Maltase break down maltose to form two glucose units, and a molecule of water is liberated. Right? Now coming on to our second type, that is isomaltose. Maltose has bonding alpha 1,4, right? So in case of isomaltose, the bonding is alpha 1,6. The two glucose molecules are there, but the bonding is alpha 1,6, right? And in case of salobios, is also a type of similar molecule, but the bonding is beta 1,4, right? So in case of maltose, we have alpha 1,4 linkage. In case of isomaltose, we have linkage alpha 1,6, right? But in case of salobios, it is also disaccharide that is formed by hydrolysis of cellulose, right? The bonding is beta 1,4, right? With structure of maltose. The code is Mg, right? The maltose consists of two glucose molecules. Bond is alpha 1,4. So this is one glucose, this is another glucose. 1, 2, 3, 4, 5, and 6. Third carbon OH is upside, so it is glucose. Similar way, 1, 2, 3, 4, 5, and 6, right? Third carbon OH group upside, so this is two glucose molecules. The bonding is alpha 1,4. So one carbon, fourth carbon, from where 1,4 glycosidic bond will form, water molecule will come outside, so we'll get finally maltose. Now coming on to our second molecule, lactose, commonly known as milk sugar, right? The component, the code is Lg, right? G for L for lactose, G for two G's. The two G's are glucose and galactose, right? The galactose molecule will come earlier, then comes the glucose molecule. The bonding is beta 1,4. Both are in beta form, right? The anomeric carbon is free, so it exhibits oxazone formation. The oxazones are powder puff in shape. Importance: it is provide nutrition for young mammals, right? Hydrolysis: lactose is hydrolyzed by lactase. Lactose is hydrolyzed by lactase. Ase breaks down lactose to finally yield galactose and glucose, and the molecule of water is released, right? Now coming on to lactulose, right? The code is GNF. It is a disaccharide. The difference between lactose and lactulose is that lactose contains glucose and galactose, but in case of lactulose, we have galactose and fructose, right? It is neither digested nor absorbed in intestines. What are the uses? It is used in treatment of hepatic encephalopathy, right? Now we will start with structure of lactose. The code is Lg, right? L for lactose, G for G has two components, galactose and glucose. First component is galactose and second component is glucose, right? And remember one thing, both are in beta form, right? So how? So this is molecule of galactose, third carbon OH group, and fourth carbon OH upside, so it is galactose. Glucose, third carbon OH group upside, so it is glucose. Both are in beta form. How? First carbon OH group and sixth carbon OH same side, so it is beta galactose. Glucose, first carbon OH group and sixth carbon OH same side, so it's beta glucose, right? The bonding is beta 1,4. first carbon OH group and fourth carbon will form bond here. Water molecule will come outside and we'll get lactose. So the components Lg, lactose, G for lactose and glucose. Lactose come first, glucose comes second. Both are in beta form. Bonding is beta 1,4,1,4. Water molecules comes out, we'll get lactose. Now coming on to our third molecule, sucrose, commonly known as table sugar, or composition code is G and F, right? G for glucose and F for fructose. The bonding is alpha 1 and beta 2, right? Reducing properties, reducing groups are not free, so it is a non-reducing sugar, right? And uses sucrose is employed as a sweetening agent in food industry. Okay. Now sucrose is hydrolyzed by sucrase. ACE just break down sucrase. Sucrose is sucrase. So enzyme intercellular enzyme sucrase hydrolyze sucrose to finally form glucose and fructose. Now coming on to some artificial sweetener, that is sucralose. So sucralose contains trichlorosucrose, right? It is 500 times more sweeter than sucrose, right? It is most common artificial sweetener used these days, and it can also be used by diabetes as well as non-diabetics, right? So it is used in baking, soft drinks, and products that require long shelf life. Now we will start with structure of sucrose. Sucrose is remembered by the code G and F. It consists of glucose and fructose. The glucose is in alpha form and fructose is in beta form, right? So this is the structure of glucose, this is the structure of fructose. The glucose 1, 2, 3, 4, 5 and 6. Third carbon OH group is upside, so it is alpha D glucose, and beta D fructose. The numbering is 1, 2, 3, 4, 5 and 6 carbon. The OH group of second carbon and the sixth OH on the same side, so it is beta fructose, right? The bonding is alpha 1 and beta 2. Bond will form and water molecule will come outside, so we'll get sucrose. So basically the structure as right, glucose, fructose, alpha 1 and beta 2. So these are the various books from which I prepared this lecture, like Harper's, Vasudevan and Satyanarayan. So thanks a lot and best wishes to all of you. Please like and subscribe my channel and press the bell button below